But, when you are deploying these service-oriented or developing and deploying these service-oriented applications, you've got all these different moving parts. In addition to SQL databases, you've got RabbitMQ. You might also have NoSQL databases. Plus, you've got all your application services as well. Lots of different pieces to coordinate and manage and so on. And so it's sort of like, well, okay, I'm going to do some development. Who's going to set up my laptop with all these different pieces? Installing the different databases, installing the message broker. Who's going to set up the QA environments and so on? And this is something that Cloud Foundry can help with. So, sort of Cloud Foundry in a nutshell. So it's a platform as a service. So you literally can just say, here's my application, go run it, and then by the way, here is the list of platform services that it needs. And it supports sort of various languages and frameworks like Java and Spring and Scala and Rails and Node. And then the community has added support for other languages like Python and PHP. There's also .NET there. And then it also supports various platform services like Postgres and MySQL, MongoDB, Redis, and those sorts of databases, as well as RabbitMQ. And then it also gives you a choice of where you can run it. So you can run it on cloudfoundry.com, or as I'm going to talk about in a minute, you can actually just run it. You can actually download a virtual machine and run the whole cloud on your laptop. So in other words, you just install that virtual machine, and you get all of these services and framework supports just bundled into one. So Cloud Foundry makes it very easy to create platform services. So if you need a MySQL database to do some testing, you just go VMC create service, the type of the service, and then the name of the service, and you have a database instance that you can use. In terms of deploying an application, you can create a manifest file that says, that actually lists out all of the services that make up your application. And then for each service, what platform services does it require? So here it's like saying that you can go find the war file for the inventory service in the inventory/target directory. It's actually a string out. It needs this much memory, and it needs RabbitMQ and MongoDB and Redis. So you can say things like that. And then here's the part of the manifest for the store, so you can find the war file for that in store/target, and it needs MongoDB and RabbitMQ. It doesn't need Redis. Then once you can create this manifest file, and then with a single command, ESC push, you can tell Cloud Foundry to create all of the platform services, so the MongoDB, the Rabbit, the Redis, and the MySQL, that your application needs, and then deploy all of your applications. So you just do that with one command, ESC push. That's pretty convenient. And then, as I mentioned, you can either use cloudfoundry.com, or you can download this microcloud and run it on your laptop. So if it's a Windows machine, you can use VMware Player. If you're lucky, you have a Mac, you can run it using Fusion. So just by downloading this one virtual machine, you get your own private cloud sandbox that you can just use for whatever purposes you want. So it's just you can develop and test within it. And then the other interesting thing is that so you can create these services within Cloud Foundry, so within the microcloud within cloudfoundry.com. And then there's you can actually create a tunnel using the VMC tunnel command that basically creates a networking tunnel from within Cloud Foundry to the outside world, so that it appears as if that database is running locally on your machine. And so there's a socket that exposes it as a socket that you can connect to. So in this example, I'm actually tunneling into a MySQL instance on cloudfoundry.com, and then I'm telling it to run the MySQL command line utility, plug the coordinates, the username, password, and database name, and port number into your integration test, and then they can just run as if they're talking to a local database. So you've got this great support for testing with all of these different languages and testing with all of these different services. So that's pretty much my talk. So it's sort of, in summary, so monolithic applications are really simple to develop and deploy, but there are also drawbacks. So you end up wanting to decompose your application into a set of services so you can develop and test and deploy and scale each of those services independently, and which makes it much more easy to adopt new technologies. And then, Cloud Foundry can actually simplify the development and deployment of those service-oriented applications with the various features that it provides. So that's my talk, and I hope you found it useful. So thank you.
You presented some patterns for handling errors.
Yeah.
So I think those patterns were for in the data. But I'm wondering how you deal with errors when you're writing data. For example, you have service A, which writes some data, service B writes some other data, and then happens some error. How do you deal with that if you're not in a traditional transaction?
Yeah, I mean, it's sort of handling those kinds of problems ends up being quite a lot more challenging. So, for instance, I mean, one approach is, so service A has its own database, right? And service B has its own database. So, like, a concrete example would be order management. So you've got the order management service that's got its orders database, and then you've got the customer management service that's got its customer data. So the order database also needs some customer information as well, right? So what you might end up doing is when the customer management service updates the customer record, you might actually send a message to the order service telling it to update its copy of the data as well. So you end up basically having to send messages around to keep them in sync. If that...
But what would happen if, I think taking an order that involves several stocks from different providers, and so, one provider fails, you can't take the stock from that provider. And how do you manage the whole transaction? Because maybe
you end up with this sort of eventual consistent, what they call an eventual consistency mechanism. So it was on the Netflix, on one of the slides, I think there was a reference to another really interesting article about it. But let's go back to the customer management example, because that's a simple one I can explain, right? So what you might do is, so you update you begin a transaction, you update the customer record, and then you also insert into this other table an entry to say, a row that says, you need to go update the order service, and then you commit the transaction, right? So that's one atomic transaction. And then there's another process that's beginning a transaction, sending a message to the order service, and then deleting the row that said that it had to send that message from that table. So that's another second transaction. And then within the order management service, you actually need to do things like look at messages coming from the customer server. So it ends up being quite complicated. But it's either the advantage of that is if you've got multiple databases, like you end up having to operate at scale, you actually have multiple databases, right? So the choices are, you either use the scheme like how I described, which sounds kind of complicated, but it's not as bad as you think it is, or you have to do two-phase commit, right? Which is quite complicated, actually has a whole bunch of issues around availability and reliability. And so if you look at companies like eBay, they actually don't use two-phase commit. They actually use the mechanism that I just described to propagate changes between these different databases. And I think in the talk there might be a link to the, there's a guy, Dan Pritchett, who wrote an article about eventual consistency in the ACMQ magazine that describes this really, really well. So I encourage you to have a look at that. But it's basically like why eBay doesn't use two-phase commit. It's sort of another thing you can Google. Yeah, at the back.
First thing, great talk. Thanks a lot. May you share your presser with us?
Yeah, actually this, a copy of this is already on SlideShare.
Oh,
Because I gave the same talk like 3 weeks ago at a conference called BlueCon. So does everyone know about SlideShare?
yeah.
Yeah. So my user ID there is chris.e.richardson. So my middle initial is E. So if you go look for me on SlideShare, you will find this presentation.
And my question is, what was your maximum challenge when you create Cloud Foundry?
What's the biggest challenge?
Yeah.
It's funny, I think in a way the biggest challenge is more of a marketing challenge, like getting the message out to people and so that, just driving traffic to the website, generating awareness so people will come to the website and sign up and try and use it. And I think that, I don't know, to me, like a lot of the technology side of things, that's easy, but the whole marketing side of things, it's always a lot harder. But the other thing is we were a self-funded startup, so we were doing things on a shoestring, tiny little budget. And this was all at the end of 2008, 2009, when the stock market was crashing. So it's more kind of marketing, finance, rather than sort of particular technology challenges. But I don't know. I mean, for me, that was very exciting. Just cloud, it was just cool and it was exciting. We sort of had fun actually doing it.
Okay.
And then behind you, there's another.
Hi. First, in your experience, how do you change the mind of a young development team building monolithic applications? What's the path to change that habit?
So, how do you change their minds? It's more, I think it's one of those things where as time goes on, say you're successful, your application gets bigger and bigger and bigger, and then you start feeling the pain of having this monolithic application. And then then you get it into your head that yes, we should start refactoring it, splitting it apart into separate services. So I think it's, people often don't change until they feel pain.
I have another one. I have faced a little bit Cloud Foundry and also the new platform called Elastic. Do you know about Elastic?
Yeah, it's funny. I actually met the guys behind it at Java 1 last year.
Good, because
but
I think Cloud Foundry is good. I have deployed one or two monolithic applications, but I have played around with Elastic. and I think it's a little more intuitive or easier to go.
Well, they actually have quite a nice UI, right? I think they have quite a slick.
It's very easy to use. The deployment model is monolithic.
Yeah. I mean, I know that they have a nice user interface where, I mean, right, it's kind of like cloud. I mean, the interesting thing about Cloud Foundry is it's actually an open source project, and so yes, it's running on cloudfoundry.com, and yes, you can download the microcloud, but then you can also, then people are actually downloading the source code and running it in-house, and then there are other companies who are taking Cloud Foundry and built their own platform as a service on top of it as well. So like, I think like Apple, they built their own cloud, and I've heard that actually has a nice user interface. But I mean, it's a cloudfoundry.com doesn't yet. But there's nothing to stop you from building a user interface for it using the web service API. And that's how, I mean, there's various plugins right now for like STS, the Eclipse-based IDE, and also Rails and Groove that leverage that web service API as well.
Thanks.
Yeah.
How would you go on refactoring a big application into smaller ones?
It's kind. I mean, it's funny. I've actually gone back and tried to do that with older projects, and it's actually kind of challenging because you end up with everything is connected to everything else, and it ends up being a problem that okay, so you've got this big application, you want to extract a service out of it, so you look at a set of classes that you think would make a reasonable service, but then you sort of have to go, you end up having to break the dependencies between that service and the rest of the application. And it can be quite challenging. I mean, it's not necessarily easy. But there are a few things that you can do. Actually, there's a longer version of this talk on slides that does talk about that in a bit more detail. But for instance, one thing one way of breaking dependencies is you end up with two versions of the class, right? So in the service, you have one simple version of the class, and then in the rest of the application, you've got a more complicated version of the class. So you end up then you end up with that situation that I described earlier with order management, customer management, where you end up replicating data between the services asynchronously. So there ends up being a bunch of challenges around it. So you might end up having you start splitting things up and you get 300 compilation errors, and you just end up having to go through and break up the dependencies, and you spend a week doing it. So that helps. Yeah.
Maybe this is off topic, but you enjoy developing in Spring, as many of us, but in the user interface, what's your favorite, or what framework do you use almost always, or what's your first choice?
Yeah, interesting. So yeah, I mean, I'm a huge fan of Spring. One thing, so if I was implementing something that exposed a RESTful web service, I would just use the Spring framework for that. It's quite a good framework for building RESTful web services. But then if I was building an application that needed eventing between between the browser and the backend service, then probably RabbitMQ. But in general, yes, Spring. I mean, if I was just to pick a job, if I was going to pick a sort of more traditional web application framework, I would just use Spring. Yeah.
Testing this kind of product because computer is more easy, maybe because all the things are separate.
Yeah, I mean, I think you could make the case because yes, you've broken up your application, and each service has a very well-defined interface, and it tends to be small, so you can just test. So that there's a good argument to be made that things are simpler to test. I mean, there are. I mean, where it gets hard is if you want to do a sort of a large system test, then you've got to fire up all of these services and initialize each of their databases and push messages in and make sure that the right things happen. But even with things like Cloud Foundry, even that's you can automate that. Yeah.
Well, I'm thinking that with an architecture like this one, or something like that, you end up with a bunch of services that you want to know about the health of the services. So, if, for example, if some service dies, you want to be it up and running as fast as you can. Does Cloud Foundry provide some infrastructure for monitoring or restarting your services without you worrying too much about it?
And I mean, the short answer to that is yes. I mean, one part of Cloud Foundry is a health monitor. So if a service just dies, for example, like you can say, when I deploy my application, I need 5 instances of that application. So if one of those instances dies, the Cloud Foundry health monitor will detect that and restart it. So there is this sort of healing mechanism built in. I mean, it does get more complicated, of course, when things don't die, they end up in some kind of zombie state. And then you'd have to have some application level monitoring that you need to implement yourself to detect those kinds of failures.
Talking about scalability, for example, I have one application, and I need to increase the power, the infrastructure. Then I can do this kind of thing. I can increase the memory, increase the instance, and all this kind of thing.
Certainly you can. I have to go look to see whether you can increase the memory. I can't remember that, but you can just increase the number of instances. So from the command line, you can go VMC instances, application name plus 3, and that will just add 3 more instances of that application. And then if you want to scale down, you can just go -2. Kills off 2 instances. Any other questions?
Do you know if Cloud Foundry has a strategy for providing in some way education or a strategy of education in Mexico related to universities or just
I'm not aware that we have any strategy in that area. I mean, interestingly, because it's open source, there's nothing to. Someone could just download the source code and fire up a Cloud Foundry service. Yeah, I forget. I don't know who I was talking to today. Yesterday, I was talking to someone who said that they had to run their application in Mexico, and had to be in country, and then that would be a scenario for either them or some third party firing up the Cloud Foundry.mx service. So maybe we registered that domain name. Yeah.
I like the event-centric applications, service-centric applications, but I had a headache. cases, control flow, workflows, and you say that some components die, some components survive, and I got the idea that in this approach, service survive both the use cases, the entities, the domain model. I don't know, I have a little problem how to start an application like that.
Well, I mean, I suppose a number of different things can happen. I mean, some of your use cases could just be specific to a particular service, right? So it could be an order management service that just has an API for like create order, update order, that kind of thing. But then more complicated use cases could end up spanning multiple services. So you end up with issues where, say and then you want to implement a use case, so several teams might have to coordinate their development efforts in order to implement that use case because it spans all of their different services. So interestingly, even within a monolithic application, you might end up with certain people are responsible for certain parts anyway, and you still might have to have a discussion involving multiple people anyway. So it's just, I think it might have made things a little more complicated, but you often have that problem anyway. Yeah.
You talk about Cloud Foundry Cloud Node.js. Is it using in production mode?
Oh, is Cloud Foundry useful in production mode?
Yes, Cloud Foundry Cloud Node.js.
Well, Cloud Foundry is in beta right now, so it may or may not be a good fit for your application in production. I definitely know of people who have downloaded the source code and deployed and have put applications into production using their own private in-house copy of Cloud Foundry. And I think that might have been probably Java applications. But the Node stuff is in pretty good, as in its support, it's in good shape. It's just running standard version of Node. Anything else? Great, thank you. Feel free to contact me and email address is up there and Twitter's there. You can look for the presentation on the SlideShare as well. So, thank you. It's funny, right now my son is playing a baseball game. Apparently his team is up.
Solo que el premio ya lo tengo.
This is like the playoff. Actually, it's like the World Championship within the region. So they're winning, which is good. Oh, great. Thank you.
Vamos a la parte de los regalos.
Bueno, vamos a
Tenemos
cuatro talleres que se van a dar con preguntas, como siempre.
Yeah.
Una licencia de idea. Bueno, primera pregunta.
¿Cuál es tu Twitter?
¿Ok?
¿Cuál es tu Twitter?
Todos van a decir Bene, pero no, el guión bajo Bene.
So, you can explain what the circuit breaker pattern is.
service doesn't respond very often, you call the service and you provide some other response, some page response.
That's good. I mean, temporarily.
Que las firme, que las
Bueno, pregunta, en la parte de comunicación, comunicar servicios, Chris recomendó dos frameworks, uno para concurrencia y otro para Enterprise Integration Patterns. ¿Alguien puede recordar cuáles dos eran? Primero que alzó la mano. Pónganse listos.
entonces la dejo levantada.
Porque no van a tener que hacer pensar otra vez.
Algo que no se me da, ¿no?
Pero el otro era concurrencia. Concurrencia. De hecho, Pista, hace 2 ediciones, Venkat habló de ese framework.
A ver,
Sí, se acordó.
hay una más fácil porque están muy manchadas. ¿Por qué es importante reescribir las aplicaciones cuando son chiquitas para tenerlas en la última tecnología? ¿Qué es lo más relevante de eso?
Que las cosas chiquitas que hacen bien las cosas, bueno, como las utilidades de Unix, cosas chicas que lo hagan bien.
Casi.
Para que no te duela, ¿no? Sí lo dijo.
Sí. Otra, bueno, sí, pero...
Es difícil, cuando ya lo tienes grande, cuando lo quieres refactorizar para obtener los beneficios, es muy difícil hacerlo. Entonces es mejor desde el principio tenerlo chico y bien pensado.
También iba más, bueno, también, a ver, por ejemplo.
Pues, con varias aplicaciones chicos puedes tener un equipo para cada aplicación, porque puedes cambiar un servicio sin tener que cambiar todo.
Pero, acuérdense el punto de cuál es la importancia de tenerlo en la última tecnología. O sea, puedes tenerlos muy chiquitos, pero siempre tenerlo en el mismo stack, pero ¿cuál era la importancia de estarlo relevando de por ahí?
Es que lo importante es que cuando relevas tareas, sencillamente puedes corregir o puedes ubicar los errores y bueno, el código de donde vas, y es factible de que lo haga mucho más rápido.
Y no importa con qué está hecho.
¿Pero qué es lo relevante de poder cambiar de lenguaje?
Porque la gente se mueve con
La quería.
Si los chiquitos se empiezan a renovar, entonces siempre estás. Obviamente, los chicos tienen todos los momentos.
Muy bien. Bueno, siguiente pregunta. Chris mencionó, todas las ventajas de Node.js y mencionó que era una alternativa que es algo parecido, pero corre en la máquina virtual de Java. ¿Cómo se llama? No le llegó.
So I want to say though, at Gwendolyn on Twitter, don't be
Yo tengo mi cosa de video, nunca más. Qué desperdicio.
La última por la licencia.
It's going to be tough. Okay, let me look back to the slides. I've never been asked to create questions before. It's tough. actually maybe one question is why is asynchronous communication better than synchronous communication? Why is message passing the preferred way to do it?
Yeah.
Because with synchronous communication, there's no delays between. As you explained, there could be two processes that are not dependent, so you can run it concurrently with an asynchronous call.
Oh, I don't know about that.
Dijo, no sé qué dijo.
Acá.
No, I want to hear a better one.
Because you do not stop, you continue.
Say that again?
You do not stop, you continue.
Yeah, I mean, I guess that's better sound. Sorry. Yeah. So yeah, another way of putting it is to actually decouple producers and consumers.
Bueno, pues eso es todo. Muchas gracias por venir y nos vemos la siguiente. Muchas gracias a Chris.